Let's take some time to become familiar with the graph of exponents and logs together. And if hopefully this will help with both of the graphs for you because we will be doing some exponential graphing still. So first, let's start pretty simple. Y equals 3 to the x. Okay, so I recommend that you just make a little table of values. So x and then the y is the 3 raised to the x. And then you want to put a couple points on, and you want to at least have -1, 0, and 1 for x. And then you might want something like 2 just to see kind of where the graph goes a little better. And then you quickly plug in 3 to the x power. So 3 to the negative first is 1/3. 3 to the 0 power is 1. 3 to the first power is 3. And 3 to the second power is 9. And then remember, in your table, you're also going to want to write that you have a horizontal asymptote at y equals 0. And then let's graph that. So we're always going to need to have one of those little fractions. Okay, this should look very similar to the graph of 2 to the x above. It just actually rises a little quicker because it's being multiplied repeatedly by 3 instead of by 2. And then you want to extend that towards that horizontal asymptote in the negative infinity direction. Okay, lovely. So now let's talk about the domain and the range of the exponential function. Okay, good practice, good review, right? So the domain, look at that. It goes on forever in the negative infinity direction, and then it goes on forever in the positive infinity direction. So the domain is all real numbers. I like to write the little fancy R because it's fun, but you can also do negative infinity to infinity in parentheses. Okay, now the range. Notice that there's nothing in the y values below 0, and the range doesn't actually hit the 0, so it's a parenthesis. Right? It does not include 0. It starts right after 0, and then it goes up forever. So that's 0 to infinity. Okay. Okay, so if we are going to graph log base 3 of x, I think the easiest way to remember how to graph log graphs is to base it on the exponential graph. So this is the inverse of y equals 3 to the x, right? So if it's the inverse, that just means that this table, all the points are flipped with the x's and the y's. So let's make a new table. This is x, and this is log base 3 of x. Okay, so just switch the values. So 1/3, comma -1, 1 0, 3 1, and 9 2. Okay, and then remember, instead of a horizontal asymptote, you're going to have a vertical asymptote at x is equal to 0. Okay, so let's graph that. 1 0, 3 1, and 9 2. Okay, that is rising, just rising slowly there. And then here at the vertical asymptote, it's going straight down towards that lovely vertical asymptote. Okay, so now if we talk about domain and range, see where I can fit that out. I'll just stick it right here. The domain and the range. Okay, so the domain is definitely not all real numbers this time. Notice there's no negative x values. In fact, x starts right after 0. So parentheses 0 to infinity. Now the range starts at negative infinity on here, and then the y values continue going up forever. So the range this time is all real numbers. Okay. If you remember something about inverses, let's connect that back to our last section, right? The domain and the range of the original will switch for the domain and range of the inverse because x and y are switched. So domain and range will switch. Okay, so it confirms that. Of course, that would still be true. That's what we learned in the inverse section, and here we are using it. Okay, let's do another. So I do want you to think about these graphs basically in terms of transformations, right? So if you want to graph this next function using transformations, that's great practice from earlier in the course, and it's an easy way to graph. If you don't want to graph using transformations, you basically just need to plug in some points for x. Make sure you're plugging in points that will help you get the like the middle of the graph, the meat of the graph. Okay, so in other words, in this problem, I wouldn't want to plug in 0, -1, and 1, because then I would be doing like 2 to the 5th. I don't want to try to graph 32, which is 2 to the 5th, right? I would have to actually graph like -5, -4, and -3 for x, right, to get that meat of the graph. So if instead, if you want to this is the original graph would be y equals 2 to the x, and then it's a shift, let's see, to the left, 4, right? So in other words, it's x minus 4. So your original y equals 2 to the x, we have a chart of that above, but since I can't see it, I'll write it down for us. So that's x and y, and this is just the 2 to the x graph, because we're doing this using transformations, remember? Okay, so let's see, -1, 0, 1, and then this is 1/2, 1, and 2. If you're wondering how I could do that so fast, I actually kind of memorized these 3 points, which was the last video that we did. It goes through those points: -1, 1 over a, 0, 1, and 1, a. So I find it easiest to just memorize those and quickly use them. Okay, so our transformed graph is x, and then this is 2 to the x plus 4. So remember, we're going to do x minus 4 for each one. So instead of -1, subtract 4, you get -5. But there was no transformation in the y direction, so that's 1/2. And then 0 minus 4 is -4, and then the y is still 1. And then 1 minus 4 is -3, and then the y is 2. Okay, so to graph the new graph, we go over to -5 and then up to 1/2. We go to -4 and up to 1, and we go to -3 up to 2. Okay, so here, and then up. Okay, and then we know that our horizontal asymptote, I should have written that down, but the horizontal asymptote was y equals 0. And then since it was just a shift to the left, the horizontal asymptote is still y equals 0. Okay, so let's talk about the domain and range. Oh, hey, aren't they the same as the last one? The domain is all real numbers. Every value can be put in for x. The range is still 0 and up, so parentheses 0 to infinity, or not including 0. Okay? All right, so then finally, let's graph the. Okay, so now let's take a look at what looks like it might be the inverse of the graph, the exponential that we just did, right? So log base 2 of x plus 4. So the issue is that since we did a horizontal transformation in the exponential form, a horizontal transformation in the log form is not going to be the inverse, right? Since we have a horizontal transformation in exponential form, to do the inverse, you switch the x's and the y's. So we would actually need a vertical transformation. I think it would be just like a -4 at the end of the equation in order to be the inverse. So this is not the inverse of this, contrary to popular opinion. So not the inverse. Believe me, I've tried to make it the inverse before, but I promise it is not the inverse. So these two are not inverses of each other. So we're kind of starting from square one on this one, log base 2 of x plus 4. So I think that we should just graph this using transformations the way we just graphed the exponential using transformations. So our original log graph would be, here's x, and y would be log base 2 of x. Now I'm just using log base 2 because I want to use this base that they've given me. That will help me graph. And remember, for the logs, instead of having 0, 1, I would have 1, 0. Instead of having negative 1, 1 over a, I would have 1 over a, negative 1. Oh, and sorry, we're using 2. So I'm going to switch that a out to a 2 for this specific problem since the base is 2. And then instead of having 1, 2, I would have 2, 1, right? So this is the standard, the parent function for the log. And that now for my transformation, it's x plus 4. So this is a shift left 4, just like on this one. So let's take a new table. So this is x, and this is log base 2 of x plus 4. So since it's a shift left 4, we're going to do x minus 4 for every x value, okay? So that's kind of inconvenient for this first x value, but we'll do it anyway, I guess. 1/2 minus 4 sounds like negative 3.5. Just need a good point for the graph, right? And then that's the y value did not change. And then we would have 1 minus 4, which is negative 3, 0. And then 2 minus 4 is negative 2, 1. Okay. And so let's plot those points. Oh, and then also we would have, since we had a vertical asymptote, this is the vertical asymptote. The original vertical asymptote is x is equal to 0. Since we're doing a horizontal shift, it's affecting the x's. Our new vertical asymptote is at x is equal to negative 4. Okay, I subtracted 4 from 0. All right, so first of all, vertical asymptote at negative 4. Okay, and then let's see, negative 3.5, negative 1. Negative 3, 0, and negative 2, 1. So remember how the log graphs look. They're going to go towards that vertical asymptote, and then they're going to slowly rise to infinity there. Okay. And then if we want, we could do the domain and range here. So the domain would start at that negative 4. So parentheses, negative 4 to infinity. And the range is all real numbers. Okay, no numbers are missing.